All right, question number 1. We're looking at FRQ number 4 from Unit 4. So a financial institution, 40% of transactions are suspicious and they block them. And there we go. That's all we really need to know. They could have just told us that and we can answer all the other questions. So when we get to A, so circles. So if you have 136 transactions, how many are going to be blocked? Well, we expect 40%, so I times this by 0.4, and I did do this one for you, 54.4. They would have actually accepted any answer between 54 and 55. So you could have rounded down or rounded up, but you'd have to say blocked. Or, oh no, you'd have to put expected block transactions. I'll be honest, I was sitting down and reading the scoring guide for this, but I'm just going to pretend like it's they're looking for 3 things on this one to get the E. You needed to show your work, so you needed this. They wanted the number, and you need the context. Okay, you need all 3 of those things to get full credit. If you missed any one of those things, it was a P, I think. All right, so that, remember, expected value is percent times your total. It's expected value. Any questions on that one? Yeah. Yes, you are supposed to use complete sentences. So there would be 54.4 expected block transactions. If anyone from the College Board is out there and watches this for any reason, you need to change your grading system because your grading system's dumb. All of a sudden our school's blocked from having AP tests. Like, this teacher doesn't appreciate us. I don't. It's silly. Do what AP Bio does. It's just like 3 points, 1 point for each part. Boom. It's not rocket science. This is a math test. I could see an English test doing that, being like, all right, here's the rubric. And that makes sense to me, because you're looking at overall quality of writing. This doesn't. You're right or you're wrong. It's math. That's why I teach math. I can't grade the paper. All right. Look at this beast. So they want to know how many transactions they will have to go through before one is blocked. So what we're looking for BI, that also is silly. For BI, we're looking at number of transactions, right? That's our variable we're defining. We want to know how many, whenever they ask you what's the variable, it's what are you looking for? Number of transactions. Now, you would have also probably gotten credit if you wrote trials. Number of trials. How many trials until we get one that's blocked? Now, remember, if you're ever looking for number of trials, that is a geometric distribution. Geometric is how many trials until success or failure. Okay? This was a 2-pointer. I'm just going to call them points, okay? 2-pointer. You get both. That was an E. 1 was a P. 0, it's 9. Yeah.
Number of reviews work?
Yep. Number of reviews would work for the variable that you're looking for. I guess it would be number of transactions reviewed. That'd probably be the better answer. Now, expected value. Don't forget, this is on your formula sheet. Geometric expected value is on your formula sheet. And it is 1 over P. 1 over the probability. For this one's 1 over 0.4. So it's 2.5. Now, we need to interpret in context. So, to do so, you would say something. You would say, on a given day, we would expect the number of trials or the number of reviews until one is blocked to be 2.5. Okay, on any given day, we'd expect the big things here is we expect the number of the reviews, and that would be how many until we hit one that gets blocked. Okay. Any questions on that one? Yeah. Did you say until one gets blocked? Then no, they wouldn't give it to you. That's how many trials until you get one that's actually blocked. Or how many, you could say trials, you could say reviews, whatever you need to. All right, and C. All right, on C. So let's say now we have 10 randomly selected transactions. What's the probability that 2 are going to be blocked? So for this one, for CI, we are looking at, what are we measuring? How many are blocked? And now this one, we have a set number of trials. If you have a set number of trials, it is a binomial. Again, you need both to get the E. One gives you an I, or one gives you a P, and you just write, if you do this, that'd give you an I. Okay, you just drew that. Then C2, now you could do the formula for this one. You guys know the binomial formula? It is on your formula sheet. There's a combination. I did binom C. Nope, not CDF. You don't do CDF because CDF, you add up from 0 to that number. Cumulative, you're adding up. PDF gives you one specific data point, and it's NPX, where N is your number of trials, which for this one was 10. The probability of a block, 0.4, and we're looking for the probability of 2 out of 10 being blocked. What? You just plug it in your calculator in the distributions. Just like you do the same thing with geometric if they're looking for number of trials until X. And that was just NP. Geometric's just NP. And they'll give you the probability that it took that many trials to get your first response. CDF will add them all up. Okay. All right. I'm actually going to write that up there because if you know those two things, you're actually in good shape. PDF is one specific, and you do NP. Number of trials that you're looking for, probability of a success, N1. And that'll give you the probability that you hit the first one on that trial. All right. Oh, by the way, this was 0.1209. And that one would be, they're looking for 3 things again. You don't have to put it in context what it means because it didn't ask you, but 1 point for work, either the equation or that, 1 point for the right number, and I guess you'd have, in complete sentence would give you a third context, be like, there's 0.1209 probability that 2 transactions will be blocked. Okay? That's a three-pointer, or you need 3 things. All right, that was number 1, right? All right, I gotta get through number 2 quick for Isaiah, because he doesn't know. This probably won't work as soon as he leaves. This, I mean Isaac, because this video won't work as soon as he leaves. Probably he'll just quit working like last time. All right, look at Mark, Miggy. Quit baseball. Is playing golf now. Do you really play golf, or do you go shoot? I don't know. All right. What's the probability that Miguel's score is at most 5? So at most 5 means 5 or less. So for this one, you need to show your work once. Wait. Show your work. So they want you to say 0.15 plus 0.4 plus 0.25 equals 0.8. So another 3-pointer. 1 point for work, 1 point for point 8, 1 point for saying that point 8 is the probability that his score is at most 5. That's not too bad. Now for expected value, you could plug this in your calculator and put this in L1 and this in L2, and then do second or do your var stats, and then put frequency as L1, and then L2 is your data. I wouldn't for expected value. Expected value is your x times p of x plus your x times p of x. So I'm going to do 3 times the probability of 3. It's kind of like what we're doing on that weighted. It's a weighted average, actually. Because, yeah, you could get, if you did this to middle schooler, they're going to add these up and divide by 5 and get 5. But you know that some happen more than the other, so you got to weight the mean. 3 times 0.5 plus 4 times 0.4. This is actually quicker than doing it in your calculator. But now if they ask you for standard deviation, please go to your calculator. I'm not going to show you how to do that longhand again because you will not have time to do it. Because you'd have to find this first and then go through and do it. And I didn't do this one yet. Does anyone think they have it? That sounds... I got 4.92. No, I got 4.55. So we have to interpret that. Now this one, you need the work. If you use calculus, say, plugging into var stats, you need the answer. And then what this would mean, your expected value would be, if Miggy plays a hole many times, you have to have them many times, his average score will be a boot 4.55. Okay. Expected values given many trials, that's what we'd expect the average to be. Remember probability, you always interpret probability as given many trials, that's what we'd expect the average to be about. And Isaac, you can leave it anytime you need to because I think your bus leaves at 1:30. Yeah, this will be posted. Yeah, just run there. Not that. All right. So let's say he found out that one of his issues is if he hits the ball short, his expected score is 4.2 unless, wait, no. If he tries to hit it long and it's successful, he gets a 4.2. However, if it lands in the water, he gets a 5.4. So if he goes for the long shot, if he doesn't hit in the water, he gets a 4.2. If it goes in the water, he gets a 5.4. He finds out that 40% of the time he hits it past the lake without going in the water. So should he keep hitting it past long ball or should he be hitting the short ball is what it comes down to. So what you do is you do your point, there's a 0.4 of the time he gets a 4.2. So you're finding the expected value of this long ball. Plus 60% of the time he gets a 5.4 doing it this way. So when I do that, I get an expected value of 4.92. Now that 4.92 is greater than what we found on B of 4.55. So what I would tell him is, since that's higher than before, you would tell him not to hit the long ball. So for this one, you're looking for, you need to show the expected value, and that's greater than the other question. And then you'd have to answer the question by saying he should hit the short ball because his expected value is lower than when he hits the long ball. Okay? All right. Miguel. I gotta be careful. That's not. No. Can't draw. Hey guys, look, it's me. If I fell in some ice or in some cold water, I'd be iced tea. All right, good talk. All right, now let's say, so Miguel wants to find out what would his probability of a successful long ball hit have to be in order to make it worthwhile. So we know the score is still going to be 4.2, and the other score is going to be 5.4, right? Now before we had 0.4 was chance of success. So here I'm going to put a P here. And this is going to be 1 minus P, right? Because they have to add up to 1. So I want to know when I plug in that score, when will it be greater than, or I'm sorry, when will it be less than 4.55? Is the way to think about it, right? When I solve this, when can I get that to be less than 4.55? So from here, it becomes algebra. I get 4.2p plus distribute 1, oh, no, 5.4 minus 5.4p. When's that going to be less than 4.55? Actually, I'm going to make it equal to, and then we can interpret. Because golf's a little bit tricky because I'm realizing when you get this, it's not going to be your final answer. So just a fair warning. So I'm going to find out when it equals the probability and then think about how to interpret that as an answer. Because I actually want that probability to be higher because I'm doing the probability of hitting the ball well. Okay. If I would have put my P over here, then I could have kept it less than. But I didn't want to do that because I want to find it. When I do that, I get 5.4 minus 0.8p equals 4.55. Yep. And I subtract it over, I get negative 0.8p equals something. I don't know. Help me out, somebody. Negative.
No, for the 1 negative 0.8, I know. Negative 1.
Oh, yeah. You silly goose. You're right. This is what happens when I don't work out the problems ahead of time. Help me out, somebody. I don't have a calculator.
No, that's negative 0.8. 4.55.
Yeah, do 4.55.
Negative
0.85. And then I divide by negative 1.2, right? Thanks, Dwayne. You're a good guy. And I got Felipe. I got P is 0.708. Good. That's good. So now when I look at this, that's for a good hit, right? So I'd have to say his probability has to be greater than, of a good hit, has to be greater than 0.708. And, yeah. How did you do it? You would get a partial on it. Because they would give you, because remember they want the work, so that's part of it. And then that, it's almost like 3 parts. You want that, the answer, and then interpretation. So they would give you a P on it. That's not too bad. If you get, hey, that's the end of the video. Congrats.